This is the other side of web app security. So what are we going to talk about here? We're going to talk about securing users and their browsers and their computers. And we're not going to be talking about securing your servers or the data on them or your network or anything like that. So before we get started, can I just have a quick poll? Who here runs a website for any definition of runs, maintains, contributes to, and so on? Okay, keep those hands up, please. Does it support HTTPS? Leave your hand up if it does. Lower it if it does not support HTTPS. Shame on you. If you put your hand down, shame on you. But does it enforce HTTPS? Put your hand down if it doesn't redirect users to HTTPS. Shame on you. If you support HTTPS, you should be pushing people towards it. And keep your hand up if you use HSTS. Okay, I'm not going to shame you. This is what this talk is about, but congrats to everyone who does. So just a very, very brief primer, HTTPS, SSL, TLS. These terms mean subtly different things, but in the context of web development, they basically mean the same thing, which is a method of encrypting traffic to and from a web server using a server-provided certificate. If the certificate is signed by a trusted party, it also gives us a degree of confidence that the server we're communicating with is actually authorized to speak on behalf of the website we're trying to visit. Certificates can also be self-signed or otherwise signed by someone else. These are mostly worthless for the context that we're discussing them. And once we've established the other side possesses a trusted certificate, the chance of you being MITM'd, which means man in the middle, which is a man in the middle attack, or being spied on drops by orders of magnitude. It's not bulletproof, but you've already put in like a security door while your neighbor has like just a paper thin old style door, so they're the ones that are gonna get mugged. So I'm going to talk about briefly about forcing HTTPS and its pitfalls. Now, forcing HTTPS means redirecting any plaintext traffic to HTTPS. You should be doing that because people who come to you over an unencrypted network get bumped to the encrypted connection, and that's good. That's what we want. But there's also bad in many ways. One gotcha with forcing HTTPS is that it obscures and hides the fact that certain things still point to your plaintext address. Because you have automatic HTTPS upgrade, you don't notice, when your developers are building your website, when other people are integrating with it, because things get automatically upgraded, you don't notice it. You can have a login form that points to the unsecure address. Browsers will catch this mostly, but if it's a login form or something coming from a different site, then that's not going to get caught. One very tricky example that I noticed in the wild is OAuth callbacks. If you implement login with Facebook, login with Google, all of those things, at the point when you send people there to log in to get their credentials and come back, you have to construct a callback URL. You have to tell Google, Facebook, whoever, where to send the user back. And those addresses, as generated by frameworks, will sometimes be plaintext. And you'll be working on a site for months or years and not realize that someone before you who set up the system whitelisted the plaintext address, and that you are basically leaking the fundamental, like the login tokens and so on. So just blindly redirecting traffic exposes you to this thing, and you should be very aware of it. Another thing is that it takes people to the right place, so they will never update the bookmarks. You're forever living with plaintext links. If you don't tell Google that you're doing it, it's going to point to the plaintext. You have people bookmarking, people dropping links in forums, and so on forever. And upgrading to HTTPS doesn't work for non-human visitors. Mobile apps and other clients, libraries, and so on will not connect to you, get upgraded to HTTPS, and go, okay, I guess I should be using HTTPS from now on. They're going to be constructing links to connect to you every time from scratch. So if they're connecting to HTTP, first of all, you're duplicating every single request, because they go over HTTP. You go stop, go to HTTPS, they follow the redirect, you do the thing, and then the next request is just going to be over plaintext HTTP. So you're leaking every single request. You're encrypting the responses, but at the point of, so also it breaks post requests that cannot be replayed easily. They're going to be redirected. But the most fundamental problem is that the redirect itself is not secure. The redirect itself is happening over plaintext. So a man-in-the-middle attacker could be intercepting the redirect and giving you the actual content while they follow the redirect. So they're using your site over HTTPS, and they are serving your users a plaintext version. This is something that has been spotted in the wild many times over. So enter HSTS. Is it the magic bullet? So first of all, what is HSTS? HSTS stands for HTTP Strict Transport Security, and it's a response header that says, don't even attempt to contact me over plaintext HTTP for the next X seconds. So this is what the most basic version of that header would look like. And what do browsers do? They record this, and any attempt to go to your site over plaintext HTTP gets completely invisibly rewritten to HTTPS, regardless of whether it comes from an external site, whether a script, whether it's a bookmark, whether it's anything at all ever. Any attempt by any trigger to access your site over HTTP gets rewritten to HTTPS completely transparently for the user. The upgrade to this is when you say all of my subdomains are also HTTPS enabled, and I would like all of my subdomains to be accessed over HTTPS. You just add so this is wrapped, but this means same line. If you add include subdomains to your response header, that will automatically mean your entire domain. Obviously, only for things that are under your hostname. So you have to serve this on the root, on the www or the naked domain, but that propagates to everything under it. There's the next step. So even with this, you still have first-time users who have never seen or heard of your site typing in an address. If they go like yourname.com, your browser is going to default to plain text. It's going to get redirected. The redirect is insecure, like we said. And at that point, so this header can only be sent over a secure link. It's disregarded over plain text. So only once they actually make the HTTPS connection will they get this header, and will their browser start enforcing HTTPS for your website. So the final goal for HSTS is HSTS Preload. So we have the include subdomains, and then we add the preload thing. And once you have that rolled out, and the max age in seconds is sufficiently long enough, something like a year, and you have include subdomains, so all of those conditions have to be satisfied, you can nominate your domain to be included in the preload list that ships with modern browsers. So it takes some months for your domain to actually make it. You have to nominate it. There's a website. I don't know if they catch it automatically. If you're a low-profile website, probably not. You have to nominate it. They monitor your site. They make sure that it actually is HTTPS compatible, that it's set to include subdomains on the main site, that it's set to preload. Eventually, Chrome, Firefox, and all of those ship with a list of domains that should never, ever be accessed over plaintext. Try it on your computers. Try to access Google over HTTP or Facebook over HTTP. It just doesn't work. It is not possible to make Chrome connect to that. You can probably force it. You can probably break HSTS through config, but like standard configuration. So HSTS Gotchas. If you can't force HTTPS, you can't enable HSTS. HSTS is not a header that works over plaintext. It's meaningless. It'll just get ignored. If you have subdomains on your domain that you're trying to protect which don't support HTTPS at all, or still need to receive plaintext traffic, you can't enable include subdomains. If you have an app that just doesn't work at all with HTTPS, then you can't roll it out to all of your subdomains, clearly. And if you can't include subdomains, you can't enable preload, which means you still have that first request. So HSTS is a must, but it's okay if it takes you months to get to the point where you're advertising it with a year-long timeout and including your subdomains and including preload. You can roll it out with like a 1-hour delay. If something breaks, you just disable it, you're down for an hour or like 15 seconds, whatever. But you can start testing with it and slowly increase the timeout. My biggest sites are now at 3 months, and I'm getting ready to just extend it to a year because it's been like that for 6 months and no one's complained. So it will hurt because you're going to find my domains had one office that I work for had the internal keycard security system on the public domain. It wasn't routed, you couldn't access it, but it exists. So as soon as someone accessed the website of the company, they could no longer access the keycard system. We moved that to a separate domain. Then the Wi-Fi management system for, again, internal office stuff. So it's gonna hurt if you have a domain that's been around for a while. If you have many web properties on that domain, it's gonna hurt. But there's absolutely no way around it. This is something that you absolutely have to do if you care about the security of your users. The next thing I'd like to touch on is cookies and secure cookies. Cookies are used for various tracking and storage purposes. You're all, I'm guessing, aware of them. But the most critical use is to keep logged in state. If someone steals that, they can impersonate your user to you, and there's absolutely no way for you to tell them apart. So what you want to do is absolutely make sure that all cookies you are sending to your users have the secure flag set on them, because that means that even if someone manages to trick your user into a plaintext connection, that cookie will just not get sent. So even if someone somehow manages to trick the user, sends them a plaintext link or something, that cookie will not get sent with that request. So they will not be logged in. This is a trivial thing to do. It's slightly tricky if your apps don't know if they're secure or not, if they're over HTTPS. It's easier if you know that all of your stuff is. Sometimes you have to set it on the load balancer because the load balancer knows whether the request is secure or not, but it's a thing that, so it's also like kind of ignored on plaintext connections and cookies, so you can also set it just blindly, but XSS. XSS is bad. Don't let XSS happen to you, the end. Just kidding. Who cares? Content security policy. This is the thing that I really wanted to talk about because this is the thing that a lot of people are just not aware of. Content security policy is also an HTTP header, an HTTP response header that reduces the risk of XSS. XSS is an attack where a malicious actor tricks your application into responding to your legitimate users with content that is then interpreted as a script and executed in the context of your website. So that script can then steal that user's tokens, can execute actions in their name, and so on. So CSP reduces the risk of XSS in modern browsers by declaring which inline or external resources are allowed. It lets you define which hosts the browser should whitelist for JavaScript, CSS, image resources, AJAX requests, fonts, media, videos, while blocking all others. And it also lets you block all inline scripts except the ones that are explicitly whitelisted, and there's a few methods of whitelisting. The combination of these two things makes XSS unusable on your website despite any backend code flaws. So just this is like a bit of theory. So here's an example. You can use a nonce. A nonce is a value that has no actual meaning. It's just a thing that you use once and you don't repeat it. So if you put content security policy and say for script, only this is allowed and anything from my own website. If someone manages to cram in a script tag that points to a different website, because of this default source, it's not going to work. But also, if someone manages to cram in an actual script, so if this thing will block external scripts being loaded, but if someone manages to cram in a script, an actual script tag with a script contents, unless it has this parameter, nonce equals this same value, it will not run. It will be blocked from executing. So please use a different nonce for each request. Otherwise, if you just use the same value over and over, someone's going to use that and put it in their script. The main thing is that when you send someone to your site, you don't know which nonce the server is going to respond with, so you don't know what to put in there. And you can just put this value easily in any of your embedded scripts. Make sure to not print out any user input or anything from the database or anything like that in your whitelisted scripts, because you just defeat the purpose. The other thing is CSP hashes. So for scripts that don't change in content, but you trust them, you can hash them and just say the script with that hash is good. The crudest and simplest way to generate the necessary hashes is to let the browser yell at you because it's blocked. So it'll say, this script was blocked from running, it's missing this hash. This is what the actual header in its fullest form looks like. It's supposed to be all in one line, but I've broken it down for readability. So this is like only allow stuff by default from my own hostname. So images and whatever will work from the same host that the page was loaded from. Oh, sorry, this means none. So this means any script that is on the same hostname or that has this nonce or Google Analytics or Cloudflare CDN.js. No plugins, no objects. Script style tags can be loaded from the same host, or it's okay to have them inline, or they can come from Cloudflare, but nowhere else. Image tags for this, media tags, fonts, connects for for WebSockets, and so on and so on. Form actions, where you can submit forms. You can make it so forms cannot be submitted anywhere else. Who can put you in a frame, and so on and so on. And the most crucial part of this is this report URI thing. So there's a service called reporturi.com that is called the same thing as this header. Basically, this thing means if a thing on my page runs afoul of these rules, ping me on this URL and tell me. And there's like a standardized thing that the browser sends to this URL. And there's a free service called reporturi.com where you get your own URI. And you just put that, start doing that, and it'll tell you when you've added a thing that runs afoul of the content policy. And sometimes that'll be a developer shipping something. Sometimes it'll be someone trying to hack your users. And the very cool thing about all of this is that there's a version of the header called Content Security Policy Report Only that will run the reporting in your console tab in DevTools and will ping your report URL, but won't actually block anything. So you can use this in production safely to find out how your content security policy needs to be tweaked. And that is how to secure your browsers in 2019. Thank you. Any questions?
Time for questions. Right here.
Thank you for your talk. Why just not kill HTTP port? Thank you.
Yes. That is a good question. The question is why not kill the HTTP port? Because to this day, browsers default to HTTP. When someone types in a URL, it's going to default to HTTP. Some of them will also try HTTPS, but it's still not like browsers default to HTTPS. But if you run an API, if you run something that only software talks to, not humans, by all means, not kill the HTTP port, but like respond with, denied. That's what I do for vhosts that are just straight APIs. No HTTP traffic allowed. If you can get away with it. There's legacy reasons and so on. You can do HTTPS upgrade and HSTS and so on and still support really legacy stuff. You can whitelist. You can say humans get upgraded to HTTPS. API traffic is allowed over HTTP, but we're going to try and find a way to make you upgrade and so on. So, but yes, long term, plaintext HTTP just needs to die. But I don't think we're there yet.
More questions? I'm going to reach you.
Hi, great talk.
Thank you.
I'm using CSP a lot,
okay.
And I've noticed that it's not really a silver bullet for client-side security. There are issues with trusting external services.
Oh, yeah.
So we all use it, and basically we need to trust them, and it doesn't prevent domain-related attacks.
Yes.
So basically, I'm allowing all of my external partners to hack my site.
Correct.
So that's kind of bad, right?
Yes. I don't think there's a way around it. But also, I think it's a good point that you raised in that you need to be aware of that, and that is a problem. What I was talking about is mostly preventing someone sidejacking your users. But yes, third-party vendors that you embed into your site have pretty unrestricted access to your site, and we rely on that every single day with all of the things. We have all of the tracking that we love and all of the banners and all of that stuff. And yes, that's a thing that is a major concern. But it's less likely to happen than XSS and HTTP, someone inserting stuff and so on. But yes, it's a concern. But also, content security policy, maybe someone will hack your ads vendor or your analytics thing. They are unlikely to cram huge amounts of code in there. They're more likely to try and, first of all, they're more likely to try and get everyone and not you specifically. So they're not going to be working around your content security policy. And also, if they just try and reference something that is outside your trusted domain, you're only trusting your ad vendor, not not whatever they link to. But yes, if your ad vendor actually turns into a bad actor, then you're just shit out of luck. Yeah.